Good morning, class.
Morning, sir.
Hope all of you are doing good. Everything is all right.
Good morning, sir.
Okay. So in the last class, we were talking about measure of central tendency. So did you guys go through some material, numericals, faced any issue, any difficulty? Anyone? If anyone has any question, please ask. Yes, Manaswini.
Sir, you had posed a question to us last class about whether or not the measures of central tendency are hypothetical or real.
Yes. So did you get the
Um,
answer?
Sir, I looked it up, and from whatever I saw, I am actually not sure. There was no proper answer, but
Okay.
I think it's hypothetical.
You think it is hypothetical? Okay.
Yes.
Okay. Who else is with Manaswini in this answer? So if you don't respond, I would think that you are against Manaswini. So you all are thinking that it is real number. It is not hypothetical. So only Yuvraj thinks she is right. Okay. Devanshi. Only two students are with Manaswini in this answer. Okay. Let me ask Yukta. Yukta? Yukta. Okay, I guess she is absent. Then Sahiba. Okay. Sahiba is also absent.
Yes, sir. Good morning, sir.
Good morning. Is this Sahiba speaking? I don't know who is speaking.
Yes, sir, Sahiba.
Yes, Sahiba. So tell me, what is the problem with the answer that Manaswini gave?
So I'm not sure, sir.
You're not
I'm, well,
okay.
it's not
Uh,
hypothetical. I just,
it's not hypothetical. All right. Kshitiz.
it's Yukta.
Okay. Let us check with others then. Kshitiz. Kshitiz is also not around. Daniel.
Yes, sir. According to me, I think it's a real number because mean is basically average of numbers of that observation, and median is the middle observation of the number. So both of them are not based on hypothesis. So I think they are real numbers.
Okay. So the right answer is it is a hypothetical number. Okay. So why it is hypothetical? So first of all, we need to understand the difference between real number and hypothetical number. So real number is basically number which is actually present. So if I'm recording some data and the number that you're getting in mean or median is present in that data. So it is not something that is not at all present in the data set. Okay. And hypothetical is any number that is not present. So real number is present in the data set. So suppose you are asked to find out the mean income, and if so, once you get this average income, and that average income, if it is always present in the data set, always, then it has to be a real number. But you may encounter a problem when the mean that you have calculated, that number is actually not there in the data set. Then it is going to be a hypothetical number. It cannot be a real number. Okay. So it is quite possible that when you calculate mean or median, the value that you are getting may not be present in the data set. So that is why it is a hypothetical number. So let's take one example. So suppose I ask you guys how many friends you have. So someone will say 2, 3, 4 like that. And when you calculate the mean value, so the mean value may come out as say 3.8. So that on an average, students have 3.8 friends. So I'm sure no one is having 3.8 friends. Either you have 3 friends or 4 friends. So that is why it has to be a hypothetical number. Clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
All right. Okay. So through measure of central tendency, we learn how to find out the central position of your data. And what is the benefit of finding out the central position? You have an idea of what kind of data you have. So suppose I'm working on the age. Okay, so what is the age of all the students in this class? And I found out that the average age is 20 years. So I know most of the students have age 20 years. So by using this 1 point estimate measure of central tendency, I can have a fair idea what kind of numbers I have in my data set. But this measure of central tendency is not giving me the entire picture of my data. So why not giving me the entire picture? So I'm telling so suppose the average age is 20 years of the students. Okay, I know many students are of age 20 years, but some students have age more than 20, some have less than 20. Okay, but by using this measure of central tendency, I have no idea what are the variations in my data set. Okay, so that variation can be captured through another point estimate that is called as measure of dispersion. So today we are going to talk about measure of dispersion. So this measure of dispersion basically tells you what is the data distribution. Data distribution around measure of central tendency. So this point is very important. Whenever you are calculating measure of dispersion, you are calculating this dispersion around measure of central tendency. How dispersed your data is around mean or median or mode, something like that. Okay. So be very careful. Whenever we are talking about measure of dispersion, we always talk about measure of central tendency first, and then we say the data is dispersed like that around by measure of central tendency. Clear? So just by telling the average or just by telling the median, you are giving some information, but you are not giving the entire information. Okay. So to give a clear idea of what kind of numbers you have in your data set, you have to talk both about measure of central tendency and measure of dispersion together. So whenever you are reporting that the average age of my class is 20 years, so you have to say the measure of dispersion. So there are different ways to find out measure of dispersion. So you have to mention one of the measure of dispersion also. Okay. So what are those measure of dispersions? So if I have to talk about the variation in my data set, so what do you think is the easiest way? You all have used that particular method. So if I have to know what is how dispersed my data is, so what do you think? Which method is the easiest one? Anyone?
Sir, is it range?
Yes, very good. This is range. Okay. So I know, so if I calculate the average is 20 years, average age, and I know the range. So suppose the range is from 18 to 23. Okay. So now I have covered the entire data set. So just by telling these two numbers, I am giving the information about my entire data set. So I know the students are between age 18 and 23, and most of the students are close to age 20. Okay. So just by giving these two numbers, I have the complete information or like a fair amount of information about my data. Okay. So there are different ways to calculate measure of dispersion. So the easiest one is the range. So there are other methods also, like the variance, standard deviation, mean deviation, quartile deviation, coefficient of variation. There are different methods to find out measure of dispersion. So I would like you guys to see a small video first, and then we can go to have more discussion over it. Okay, I'll explain it in detail. So let us first see a small video. Okay, any questions so far on measure of dispersion? Anyone?
No, sir.
Okay.
Sir,
Yes.
could you please repeat? Actually, my network was.
Okay. So which part you want me to repeat?
It's a measure of dispersion.
Dispersion. So dispersion basically, measure of dispersion basically tells you how dispersed your data is around measure of central tendency. So if you're calculating say mean age of your classmates, so that is telling you, and suppose it is coming out to be 20, so that's this number is telling you that most of the students have age either 20 or very close to 20, but you don't know how far the other students are from age 20. So definitely some students are having age more than 20, some may be having less than 20, right? So you have to capture that variation also around this mean age, and that dispersion you capture through measure of dispersion. So like we have three different ways to calculate measure of central tendency. Similarly, we have different ways to capture measure of dispersion. Okay, and what are those ways? We have range, we have mean deviation, variance, standard deviation, coefficient of variation, many other ways, quartile deviation, okay, quartile coefficient. There are different ways. So we'll be taking up all these ways. So before I explain these, I am planning to show you guys a video. So let me find out this video for you guys. I'll play it, you see that video, and then we'll discuss more. Okay, I think I have it. Okay, so before I show you guys this video, I want to see you a small concept behind range. So let me first explain this range to you guys, then we'll go to more complicated ways. Okay, so I hope you guys can see this Excel file.
Yes, sir.
So let us assume we have these okay. So these are the ages of students from a certain class. Okay. So if you have these observations, you can calculate the mean. The mean age for this class age is 24.41. So I know that if the average age for this group is 24.4, so I know where the ages are lying on the distribution. Okay. Now it is telling me the central position. If I want to capture the variation in this data set, so how can I capture it? I'll simply sort my data. Okay. So I see the minimum age here is 21 and the maximum is 28. So the range, what do you think? What should be the range here? So if you are to talk about range in mathematics, it is from 21 till 28. So range is between 21 and 28, right? But so you give both the lowest and the highest value. So that is the way that we calculate range in mathematics. Right? But if you have to calculate the range in statistics, what is the range? So the range has to be 7. I think why we not 20, just giving the difference. Can anyone guess? Kshitij is around, I guess, now. Are you there, Kshitij? Or you're absent today?
What, sir?
So what do you think? Why we are giving this single digit when we are talking about range in statistics? Yeah, Kshitij, waiting for your response. You guys don't respond to my question, consider as absent. So just by saying yes, sir, and then not responding is equal to absence. So please be very clear, be very careful. Whenever I'm asking some question, you have to respond. Since Kshitij is not responding, so I consider this as absence. Okay, let's go to the next student then. Nehal.
Yes, sir.
What do you think that in statistics the range is given by this difference and not with the two numbers, two extreme numbers in your data distribution?
I don't know.
You don't know. Okay. Let's ask Shivani then. Shivani. If you don't know it, say no. That's fine.
Uh, good good morning, sir. Sir, actually, I don't know. I'm not sure.
Okay. All right, that's okay. Sanjana. Yes, Sanjana. Tell me.
Sir, since range gives the measure of dispersion around the central tendency, and here our central tendency is 24, so therefore
Yes.
above like around so 7 is the number that will go above and below, like it's the range around the mean.
Very good. Very good. So that's the correct answer. Thank you, Sanjana. So you see, I told you whenever we are talking about measure of dispersion, we always talk about this dispersion around measure of central tendency. So if we report mean and we say the range is 7, so we know this 7 is around 24. Okay. So if you divide, you can do it like this. So 3.5 below 24 and 3.5 above 24. So that's the range. Okay, so that is why we don't need to tell both these 21 and 28. Just by saying this 7, you have an idea what kind of data distribution we are talking about. I hope this point is clear. So in statistics, if you are asked that find out the range, you have to calculate this single digit. You have to calculate the difference. Okay. Now there is something called as mean deviation. Mean deviation. So that is also another type of measure of dispersion. So what happens in mean deviation? So mean deviation is the average deviation around mean. Okay, So on an average, how much each data point deviates from the mean. So let us take this example. So suppose we have to find out the mean deviation. So the mean here is 24.41. Now if you have to so these are the x, okay, and this is my x bar. So how much each data point is deviating from mean, that I can calculate by subtracting each value from the mean. So 21 is this observation and 24.4 is the mean value. So if you have to find out the difference between the observation and the mean, so that is how you calculate it. Okay, so it is minus 3.4. So these are the differences of each data point from the mean. Now the average of all these data points. So these are the deviations, right? How much each data point is deviating from the mean. And if you calculate the average of all these deviations, that is called as mean deviation. Now the problem here is, if you have to calculate the mean is always 0. Why it is 0? Because some values are negative, some are positive, and if you add all these, that is always 0. So if I add all the values together, you see it is close to 0, minus 1.4 into 10 to the power minus 14, which is close to 0, right? So in order to find out the mean deviation, you have to basically remove the signs, this negative and negative sign. Why we have to remove the signs? Because what we are doing here, we are basically calculating how much each data point is deviating. So this guy is, so let us assume these are the distances that you have to travel to come to the campus. Okay, so every day you travel this much distance to come to the campus. So some guy is traveling 21 kilometers, some is traveling 22. So on an average, your classmates travel 24.4 kilometers every day to come to the campus. So if this guy is traveling 21, so that doesn't mean that he's traveling minus 3.4 kilometers less. So distance cannot be in negative, right? So we basically ignore the signs, these negative signs. Okay, if you ignore the signs, so let us take this as 3.4, this is 2.4, 2.4, then 1.4, 1.4, 0.4, like this. Okay, and we take the positive values as it is. Okay, now if you calculate the average, so the average is 1.9. So mean deviation gives you a better idea. Why better idea? So suppose one guy is traveling quite a large distance. So suppose this guy is traveling say 80 kilometers every day. Now if you have to calculate the range would be very high. Okay, so just because of this guy, now the range is going to be 59 kilometers. So you'll have an idea that the students are traveling quite a distance, but that's not true. You see, majority of the students are staying quite close to each other. The observations are quite close to each other, but just because of this one extreme value, your range becomes pretty high. Okay, but you calculate the mean deviation. So mean deviation is going to minimize this impact. So the impact will be less as compared to the range. Okay, this is why range, if you have some extreme data points, range is not the right approach to find out the data dispersion. If your observations are quite close to each other, range is also fine. So the other method is to find out the mean deviation. And so this mean deviation of 1.9 is telling you that on an average students travel 24.4 kilometers, and the on an average the dispersion of each, the average dispersion of each data point is 1.9 kilometers. I hope these two things are clear to you all. Any doubt, any question? Anyone?
No, sir.
Yes, guys. All right. Now I would like you guys to see a video first. Okay. Okay, I'm sharing the video for you. Okay, I'm playing it.
There are many ways to quantify variability. However, we will focus on the most common ones: variance, standard deviation, and coefficient of variation. In the field of statistics, we will typically use different formulas when working with population data and sample data. Let's think about this for a bit. When you have the whole population, each data point is known, so you are 100% sure of the measures you are calculating. When you take a sample of this population and you compute a sample statistic, it is interpreted as an approximation of the population parameter. Moreover, if you extract 10 different samples from the same population, you will get 10 different measures. Statisticians have solved the problem by adjusting the algebraic formulas for many statistics to reflect this issue. Therefore, we will explore both population and sample formulas, as they are both used. You must be asking yourself why there are unique formulas for the mean, median, and mode. Well, actually, the sample mean is the average of the sample data points, while the population mean is the average of the population data points. So technically, there are two different formulas, but they are computed in the same way. Okay, now, after this short clarification, it's time to get on to variance. Variance measures the dispersion of a set of data points around their mean value. Population variance, denoted by sigma squared, is equal to the sum of squared differences between the observed values and the population mean divided by the total number of observations. Sample variance, on the other hand, is denoted by S squared and is equal to the sum of square differences between observed sample values and the sample mean divided by the number of sample observations minus 1. All right. When you are getting acquainted with statistics, it is hard to grasp everything right away. Therefore, let's stop for a second to examine the formula for the population and try to clarify its meaning. The main part of the formula is its numerator, so that's what we want to comprehend. The sum of differences between the observations and the mean, squared. So the closer a number to the mean, the lower the result we will obtain, right? And the further away from the mean it lies, the larger this difference. Easy. But why do we elevate to the second degree? Squaring the differences has two main purposes. First, by squaring the numbers, we always get non-negative computations. Without going too deep into the mathematics of it, it is intuitive that dispersion cannot be negative. Dispersion is about distance, and distance cannot be negative. If, on the other hand, we calculate the difference and do not elevate to the second degree, we would obtain both positive and negative values that when summed would cancel out, leaving us with no information about the dispersion. Second, squaring amplifies the effect of large differences. For example, if the mean is 0 and you have an observation of 100, the squared spread is 10,000. All right, enough dry theory. It is time for a practical example. We have a population of 5 observations, 1, 2, 3, 4, and 5. Let's find its variance. We start by calculating the mean. 1 plus 2 plus 3 plus 4 plus 5 divided by 5 equals 3. Then we apply the formula we just saw. 1 minus 3 squared plus 2 minus 3 squared plus 3 minus 3 squared plus 4 minus 3 squared plus 5 minus 3 squared. All of these components have to be divided by 5. When we do the math, we get 2. So the population variance of the data set is 2. But what about the sample variance? This would only be suitable if we were told that these 5 observations were a sample drawn from a population. So let's imagine that's the case. The sample mean is once again 3. The numerator is the same, but the denominator is going to be 4 instead of 5, giving us a sample variance of 2.5. To conclude the variance topic, we should interpret the result. Why is the sample variance bigger than the population variance? In the first case, we knew the population. That is, we had all the data and we calculated the variance. In the second case, we were told that 1, 2, 3, 4, and 5 was a sample drawn from a bigger population. Imagine the population of this sample were these 9 numbers: 1, 1, 1, 2, 3, 4, 5, 5, 5, and 5. Clearly, the numbers are the same, but there is a concentration around the two extremes of the data set, 1 and 5. The variance of this population is 2.96. So, our sample variance has rightfully corrected upwards in order to reflect the higher potential variability. This is the reason why there are different formulas for sample and population data. While variance is a common measure of data dispersion, in most cases the figure you will obtain is pretty large and hard to compare, as the unit of measurement is squared. The easy fix is to calculate its square root and obtain a statistic known as standard deviation. In most analyses you perform, standard deviation will be much more meaningful than variance. As we saw, there are different measures for the population and sample variance. Consequently, there is also population and sample standard deviation. The formulas are the square root of the population variance and square root of the sample variance, respectively. I believe there is no need for an example of the calculation, right? If you have a calculator in your hands, you'll be able to do the job. All right, the other measure we still have to introduce is the coefficient of variation. It is equal to the standard deviation divided by the mean. Another name for the term is relative standard deviation. This is an easy way to remember its formula. It is simply the standard deviation relative to the mean. As you probably guessed, there is a population and sample formula once again. So, standard deviation is the most common measure of variability for a single data set. But why do we need yet another measure such as the coefficient of variation? Well, comparing the standard deviations of two different data sets is meaningless, but comparing coefficients of variation is not. Aristotle once said, "Tell me, I'll forget. Show me, I'll remember. Involve me, I'll understand." To make sure you remember, here's an example of a comparison between standard deviations. Let's take the prices of pizza at 10 different places in New York. They range from $1 to $11. Now, imagine that you only have Mexican pesos. And the prices look more like 18.81 pesos to 206.91 pesos, given the exchange rate of 18.81 pesos for $1. Let's combine our knowledge so far and find the standard deviations and coefficients of variation of these two datasets. First, we have to see if this is a sample or a population. Are there only restaurants in New York? Use the formulas for sample measures of variability. Second, to find the mean. Is equal to 5.5. Mean 103. Process is find formula that we earlier $17,093.69 pesos squared. The respective sample deviations are 3.27. Let's make a couple of observations. First, variance gives results in squared units, while standard deviation in original units. This is the main reason why professionals prefer to use standard deviation as the main measure of variability. It is directly interpretable. Squared dollars means nothing, even in the field of statistics. Second, we got standard deviations of 3.27 and 61.59 for the same pizza at the same 11 restaurants in New York City. Seems right? It is time to use our last tool, the coefficient of variation. Dividing the standard deviations by their respective means, we get the two coefficients of variation. The result is the same, 0.60. Notice that it is not dollars, pesos, dollars squared, or pesos squared. It is just 0.60. This shows us the great advantage that the coefficient of variation gives us. Now, we can confidently say that the two datasets have the same variability, which is what we expected beforehand. Let's recap what we have learned so far. There are three main measures of variability: variance, standard deviation, and coefficient of variation. Each of them has different strengths and applications. You should feel confident using all of them as we are getting closer to more complex statistical topics. Thanks for watching.
Okay. So I hope you could understand some part of it, if not all. Any doubts, any questions? Is it understood by all of you, or I need to explain it in detail? Please tell me.
So can you please explain it?
Okay. All right. So in this video, what they have explained other measures, which are variance, standard deviation, and coefficient of variation. All right. So while calculating mean deviation, what I had done, so I had simply removed this negative signs and then calculated the mean of all these deviation, and that was coming out to be, I guess, 1.9. So what we do in variance? In variance, we don't remove these negative signs. We basically take the square of it. So if you take the square, so what happens? Even the negative values become positive. So if you take the square of these values, okay, and then calculate the average. So this is called as variance. All right, but you must have seen in the video I showed, while calculating variance for the sample, we divide it with the n-1. So for calculating the average, we divide that with n minus. So if you have to calculate the average of all these values, so we have 12 observations, so it should be divided with 12. Instead, we divide that with 11. Okay, so it has to be n-1. So instead of 4.5, it should be a bit higher. So if you add all these values and then divide this with 11 instead of 12. So earlier it was 4.5 something, so now it is 4.99. Okay, so the variance for this data is 4.9. Okay, now since we have done the squaring, okay, if these are the distances, so the variance is going to be, and if these are the distances in kilometer, so this value is going to be kilometer square. So the average is 24.4 kilometer and the dispersion is 4.99 kilometer square. That is not going to make any sense, right? So in order to bring it to the original units, so what you can do, you can take the square root, right? So the square root of this 4.99 is 2.23, and this is called as standard deviation. This is your variance, right? I hope you understood what is variance, what is standard deviation.
Yes, sir.
So whenever you are talking about mean as your measure of central tendency, you have to report standard deviation as your measure of dispersion. Okay, so just by knowing these two numbers, you can have a fair idea what kind of observations or what kind of values I have in my data distribution. Okay. Now, these measure of dispersion we are telling when our measure of central tendency is mean. What if we have median as my measure of central tendency? In that case, so suppose instead of mean I am calculating median, and so let us assume I have 13 observations. Okay, so 1, 2, 3, 4, 5, 6, 7. This is going to be my median, right? If you have calculated median as your measure of central tendency, then for reporting measure of dispersion, we have something called as IQR, or in other, if you expand it, it is interquartile range. So whenever you are reporting median as your measure of central tendency, you have to report interquartile range as your measure of dispersion. So what is interquartile range? So before we talk about interquartile range, we should know what is a quartile. Who will tell me what is a quartile? Anyone knows what is a quartile? Okay. Tell me what is a percentile. I hope all of you have read somewhere or heard about it, percentile. I'm not talking about percentage, I'm talking about percentile. No one knows what is a percentile? That is strange. Okay. So percentile is basically when you divide your data into 100 equal parts. So each part is called as 1 percentile. Okay. So if you divide your data into 100 equal parts, each part is called as 1 percentile. Similarly, if you divide your data into 4 equal parts, each part is called as quartile. Clear? So you have to divide your data into 4 equal parts and each part is called as quartile. Okay. So let me ask you guys a question first. Who will answer me? Let's go to Shakti. Yes, Shakti. Shakti is absent today, I guess.
Actually, sir, Shakti is traveling.
Okay.
She is
Okay.
having some problem.
All right. Namrita.
Yes, sir.
So when I calculate the median, so this median is dividing my data into how many parts? Waiting for the response.
So 13, I guess.
13 parts. Okay, how did you find out this magic number 13? Okay, let's ask Rupal. Rupal, is
Yes,
Rupal
sir.
around?
Yes,
यहाँ
yes,
रुक
sir.
बताओ, मीडियन आपका डेटा को कितना पार्ट्स में डिवाइड करता
Sir,
है?
I think in 2 parts.
2 parts. Very good. Why 2 parts?
So because it's a median, so that will like divide it into. It will take a.
अरे भाई मीडियन हमने क्या बोला है? इट कम्स एग्जैक्टली इन द मिडल. अगर कोई चीज बीच में आती है तो वो 2 पार्ट में डिवाइड कर देगी ना मेरे डेटा को. तो 1 पार्ट इज अबव इट एंड 1 इज बिलो इट, राइट? है कि नहीं? तो मीडियन क्या करता है? इट डिवाइड योर डेटा इनटू 2 इक्वल पार्ट्स. तो मैंने बोला ना, ये बैलेंसिंग पॉइंट होता है, मेजर ऑफ सेंट्रल टेंडेंसी. तो आधी ऑब्जर्वेशन इसके एक साइड होंगी, आधा दूसरा साइड होंगी. दैट मीन्स इट इज डिवाइडिंग माई डेटा इनटू 2 पार्ट्स, 2 कंपोनेंट्स. नाउ इफ आई हैव टू डिवाइड माई डेटा इंटू 4 इक्वल कॉम्पोनेंट्स, तो मुझे क्या करना होगा? अब इसने मेरा डेटा को 2 पार्ट में डिवाइड कर दिया है. अपर पोर्शन को भी मैं 2 में डिवाइड कर दूं और लोअर पोर्शन को भी मैं 2 में डिवाइड कर दूं. So my data will be divided into 4 parts, right? है ना? So suppose I have one apple, मैंने इसको 2 पीसेस में कर दिया है डिवाइड, इक्वल साइज. तो अगर मुझे अब 4 पीसेस बनाने हैं, तो जो बोथ हाफ्स हैं मेरे पास, उनको भी मैं आधा आधा काट दूंगा फिर से. So I'll be having 4 equal portions, right? तो सिमिलरली मीडियन ने मेरा डेटा को 2 इक्वल पोर्शंस में कट कर दिया है. अब मैं अगर हर एक पोर्शन को भी फिर से 2 equal halves में डिवाइड कर दूंगा, so I'll be having 4 parts, 4 different equal parts of my data, isn't it? Right? So now
Yes,
if
sir.
I have to divide my this upper part into 2 equal components, तो मुझे क्या करना चाहिए? Anyone? I want to divide my this component of the data into 2 equal parts. So what should I do?
Sir, take median of the 6 observations, the upper observations.
Yes. तो हम लोग क्या करेंगे? जो ऊपर वाला कंपोनेंट है उसका मीडियन कैलकुलेट कर देंगे. तो आई हैव 1 2 3 4 5 6 ऑब्जर्वेशंस एंड सो द मीडियन फॉर दिस अपर पोर्शन इज गोइंग टू बी 22, राइट? एंड मीडियन फॉर द लोअर पोर्शन वुड बी 26 एंड दिस इज 24. तो ये जो आपका मीडियन होता है दैट इज कॉल्ड एज सेकेंड क्वार्टाइल. अब मैंने अपना डेटा को क्वार्टाइल्स में डिवाइड कर दिया है. 22 इज माय फर्स्ट क्वार्टाइल and 26 is my third quartile. So now these quartiles have divided my data into 4 equal components. So one part is about 22, one is between 22 and 24, one is between 24 and 26, and one is below 26, or rather above 26. Okay. So by calculating median, now I am dividing my data into 4 equal components, and the range between first and third quartile is called as interquartile range. Okay, so it is from 22 till 6. I hope it is clear how to calculate interquartile range. And
Yes, sir.
this interquartile range basically tells you the 50% data lying in the middle. ठीक है, इसके ये 25% इसके ऊपर है, 25% इसके नीचे है. So whenever you are reporting median as your measure of central tendency, you have to report interquartile range. So why interquartile range? Because interquartile range is also not affected by extreme values. So median आप तभी calculate करते हैं जब you have extreme values. Now it doesn't matter whether it was 28 here or it was 28,000. The interquartile range is not going to get affected. Always report interquartile range with median. Okay, so I think we are done with the time. So I'll explain this coefficient of variation again in the next class in detail. Okay, so I would suggest you read about range, mean deviation, variance, standard deviation, and interquartile range. Okay, we discuss coefficient of variation in the next class and try to solve some numericals also. And the questions, the queries, the difficulties that you face, bring those in the next class. So that's all for today, guys. Thank you very much. Have a nice day ahead. Bye bye.